Okay, this is the notes for section 7.3, negative integer exponents. If you haven't done so already, make sure that you pause the video at this time and read the section before continuing on. In this section, we're really, the whole section kind of centers around one theorem, and that's the negative exponent theorem. And up till now, the exponents that we've worked with have all been values that were non-negative. So exponents in which the values of the exponents were non-negative values. Well, with the negative exponent theorem, what that does is it allows us to work with negative exponents. And it says for the following, for any positive base b and real exponent n, or any non-zero base b and an integer exponent n, okay, b to the negative n is equal to 1 over b to the n. Okay? So basically, by making my exponent negative, it really means that we're going to put that, whatever b to the n is, we're going to put that on the bottom. The negative basically says that the value is going to go on the bottom of a fraction. Okay? So really what that means is b to the n and b to the negative n are reciprocals of each other. Okay? And if we multiply them together, they're going to be equal to 1. Okay? I've got this caution here, and that is a lot of times when people start dealing with negative exponents, they want to make the value of the expression negative. That does not, a negative in the exponent does nothing with the positive or negative value of the expression. So be careful with that. The negative number of an exponent does not make the value of an expression negative. Okay? All powers of positive numbers are positive. Okay? Third bullet point that I have here is that all postulates and theorems involving powers stated in 7.2 hold when exponents are negative integers. Okay? So now we're saying, all right, all of those things that we looked at, all those properties and postulates that we looked at in 7.2 will work when we're dealing with negative integers for our exponents. Okay? And then finally, the negative exponent theorem allows expressions with fractions to be rewritten without them, or vice versa, really. If we have a fraction, we can rewrite that fraction with a negative exponent. So let's take a look at example 1 here. It says write 4 to the negative third as a decimal. So what I want to do is I want to think about, well, I can write it first as a fraction and then change that fraction to a decimal. So let's take a look at what that would look like. So I can think of 4 to the negative third as 1 over 4 to the third. Well, 4 to the third is 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So 4 to the negative third is actually 1/64th. And if I do that on my calculator, 1 divided by 64, I get 0.015625. Okay? Now I'm going to show you that on your calculator as well. So 1/64th is equal to 0.015625, and 4 to the negative third is also the same thing. Okay, so let's look at number 2 here. It says rewrite Newton's law of universal gravitation. F sub g is equal to g times m sub 1 m sub 2 over r squared using negative exponents. In this formula, F sub g is the gravitational force between two objects. M sub 1 and M sub 2 are the masses of the two objects, and r is the distance between the objects. G is the universal gravitational constant. Okay, so really all of this stuff in terms of being able to write it with negative exponents is really irrelevant. But what I'm going to do is I'm going to take, so that I don't have a fraction, so I'm going to get rid of this r squared on the bottom. So I want to get rid of that, and I'm going to try to bring it up to the top. And the way that I'm going to do that is by using the same idea about that negative exponent. So if r squared and r to the negative 2 are inverses of each other, I can bring something on the bottom up to the top and change the sign on the exponent. So just changing to move something from a fraction from top to bottom or bottom to top, all that you have to do is change the sign on the exponent. So I can rewrite this as f sub g is equal to g times m sub 1, m sub 2, and then I'm going to have r raised to the negative second power. And now I have it in as a formula involving negative exponents. So using what you know about negative exponents, see if you can do number 3 right now. See if you can get an answer to A, B, and C. And then once you've done that, go ahead and turn the video back on, and I will have the answers for A, B, and C there for you. Okay, so as we look at this example here, I know that since both of these have the same base, they both have the base of p, I can subtract the exponents here. So 9 minus 14 is a negative 5. Therefore, I can write that as p to the negative 5th power. Another way you can think of that is you can think of it as being 1 over p to the 5th, and then if I want to write it using negative exponents, I could do it this way. Okay. Part B, I have 5 to the negative 4th times 5 to the 8th. Since they both have the same base, I can add the exponents together. Therefore, that would be 5 to the 4th. The last one involves a little bit more work. I'm going to first distribute or do the power of a power. So I'm going to square 2 to the 5th, and I'm going to square 4. So if I do that, I get 4 squared times 2 to the 10th, 5 times 2. And over here, I'm going to leave this as 2.5 times 2 to the negative 3rd. Now we're doing all multiplication here, so I'm going to put together the things that I can do there. 4 squared is 16 times 2 to the 5th times, well, this is 2 to the 10th and 2 to the negative 3rd. Since those are the same base, I can add those exponents and get 2 to the 7th. And then I'm going to take 16 times 2.5, which is equal to 40, and then I can say it's 40 times 2 to the 7th power. Alright, finally let's take a look at this last example. It says rewrite 4a to the 4th times 2a to the negative 3rd as a fraction with the variable a appearing only once. Well, the first thing that I'm going to do in terms of that is, since 2a is raised to the negative 3rd power, I can make that a fraction and bring that to the bottom and make 2a to the 3rd power on the bottom. By doing that, I've eliminated the negative exponent, and now we can kind of work with it from here. So the next thing I'm going to do is I'm going to distribute the exponents through the parentheses to each of those different, both to 4 and a and also to 2 and a. So if I do that, I have on top 4 to the 4th, a to the 4th, and on bottom 2 to the 3rd, a to the 3rd. Okay. Now I'm going to simplify my numbers and my variables next. So if I do that, 4 to the 4th is 256, 2 to the 3rd is 8. Now with my a's, I have a to the 4th on top and a to the 3rd on bottom, so I can subtract those, which leaves me with an a to the 1st, or just a on top. And then 256 divided by 8, if I go ahead and do that, I get 32. Therefore, I would have 32a would be the most simplified answer for the original problem.